promise that. All right, my name is Abe Haskins. I'm a developer engineer on the Firebase team. I'm based out of San Francisco. I'm here with Lauren, who is also an engineer on the Firebase team. And today we're going to talk to you about how to build an app with Firebase, how to go from nothing at all to a completed app just using Firebase. So if you saw Lawrence's introduction, how many people were here for Lawrence's introduction to Firebase? Handful of people? All right, not too many. Cool. So this is Firebase at a 30,000 foot level. We have developed products, and those are tools that you'll use to build your products. That's your database, your user authentication, things like that. We have our growing tools to help you grow, get more users, engage with those users better. And then we have the earn section for monetization, making more money, and making an actual successful business. At the core, we have Firebase Analytics. Firebase Analytics is how you know your users. And Firebase Analytics is the core of Firebase because Firebase is all about helping your users. We built Firebase to try and help your users. And at the core of Firebase, we have analytics because it relates to everything about your business, because your business is all about users. So in terms of how Firebase works as a product, let's take a step back. Back in the day, if you were building something, building a mobile app, for example, you would have a structure something like this. It might vary. It might be 100 servers instead of one. It might be 1,000 databases or several different types of databases. But it's this general structure. This is what we call the client-server model, where we have a client device. In this case, it's that tablet-looking device. We have an intermediary server that you run and you maintain and have general control over. And then behind that, you have some database that you've set up, your Redis or Mongo or whatever. And that server interacts with that database and then kind of proxies that data to the client. And if you're setting up an app like this, you're setting it up by writing a lot of server-side code. And this code communicates with your database. It defines the API that your client device consumes. And just by the nature of this, you already have a bunch of concerns. You're not just focusing on what your users care about, which is the actual experience on the device. I don't really care how your servers are set up. I just care that it works. And you, as the person running this business, you have to put a ton of focus on that middle chunk and on the database chunk just to keep it up and running, just to keep your company going. And it dilutes your focus away from what the users care about. So when we started building Firebase, we realized we could eliminate a lot of these steps. You don't have to write custom code for every database API endpoint because they're all pretty much the same. They're creating, reading, or updating, or deleting data. You don't have to re-implement an authentication system every single time you add Twitter login or you want an email password login. That's just silly. Every single one of these things has a ton of concerns that come with them, and they only grow exponentially as your company grows. So something simple like a password reset becomes incredibly complicated when you send out 100,000 of those per day. And so with Firebase, we wanted it to not only be easy to get up and running, to step out of the door with a completed great app, but as you grow, as your business grows, and we help you do that, we want to make sure you continue to be successful with the least amount of concern about servers and scaling and all of those things that your users don't care about. So with that in mind, let's look at these services and remember a bit about what these are. So develop, like I said, the real-time database is a way to synchronize and store data, so it's an alternative to a traditional database. But unlike a traditional database, you're not writing a server that interacts with Firebase. You interact with the Firebase database directly from your client. So if you're writing iOS code or you're writing Android code, you import our SDK, you point it at the real-time database, and you start reading and writing. Similar with authentication. If you want to log in via email and password, you're not setting up a endpoint that has a database behind it. You're just saying, I want to log in on your client. And we run all the servers, we maintain everything, so you just get a secure user login system that'll work for your users. And this is every single product. I'm not going to go through them now. If you want to know more about them, hit up the documentation or go ask Lawrence, who's at the booth. He will tell you in detail about every single one of these products. But this is a general pattern. It's taking something that you used to have to write server code for, spend a bunch of effort, spend a bunch of operational costs keeping your servers up and running, and we just simplify it down and you do client-side, ST-side, that feels natural in the language of your choice to consume these features. So back to our actual goal here today. We want to go and build a completed app just using Firebase. And since it's just Firebase, that means no server-side code. We leverage all the cool powers of the cloud, and we end up with something that's actually usable and shipped to our users. And anytime you want to build anything, you pretty much have to start out with an idea. So I do this game where I write down a bunch of different words that I know. In this case, I know none of these words, because I don't speak that language. But if I did speak this language, I would go and I would circle some of these, and I'd pick like, just a few random ones that I like, so I can make a social photo chat, and that sounds good. So this idea is just kind of an experiment, and this is something I really like about Firebase, that we can pick some random words and we can start putting it together into something very quickly. It's good for prototyping and getting up and running, like I said. We want it to be quick to get building, and then once you've built something, quick to be successful. But let's take this idea and see what we can do. So imagine we have a user, we have this friendly fellow who's very happy to be looking at his phone, and we have these three concepts. We want to make some sort of chat. We want it to interact with his friends, and we want to be able to upload photos. So let's just build a chat experience, something where a user can sign in with some provider that they like, maybe Twitter login, Google login, something like that. They can find their friends and chat with them, and then they can send photos back and forth. This is a simple idea, yes, but implementing this in a traditional client-server model is incredibly complicated. If you've ever written any networking code, any socket code to deal with real-time communication, that is a huge taking on. It is such a big problem. If you've ever dealt with file upload, this is something that seems so simple, taking some binary data and storing it, but there is so many edge cases and issues. But Firebase solves all of these, so this entire problem can be solved in the next 20 minutes or so. And to give you some idea of what we're trying to make, this is what it's going to end up looking like. It's called Friendly Chat. It's going to let us send messages, upload pictures, everything like that. So this is our goal. This is what we're aspiring to. Next up, we need to pick a platform. We've created an idea. Now we've got to figure out how are we going to distribute this. We have a lot of platforms at Firebase that we support. In fact, this isn't even all of them. This is all the first-class ones that we say are highest quality SDKs that we have the most documentation about. But we have some other beta SDKs in like Unity or C++ if you're interested in developing those. But here we have Android, iOS, C++, and web. Today we're going to focus just on web. And the reason I'm doing this is because the code snippets are a little shorter. There's a lot more boilerplate to get an Android app up and running. But Firebase works everywhere. So whatever we're learning and doing today, changing it to work in iOS will be just a matter of importing the iOS SDK and changing it to the right type of code. All the features, all the functionality is there on Android, iOS, web, etc. So just because we're talking about JavaScript, don't think that you have to be building something in the web to be doing this. And it's also worth noting that if you're building something cross-platform, you're building an iOS app and an Android app, that's going to work great with Firebase because the same cloud services available to you in one are available to you in the other. So let's actually write some code. The first step to actually building an app is writing some code generally. I'm sure someone has built an app without code, but I don't do that. So we need to include this library. And this is the only snippet in here that is cross-platform. And I just want to do this to demonstrate that in each environment, although the code is similar, it feels natural in this environment. So in iOS, we include a Firebase core, which is that analytics core, plus some other core Firebase aspects. And we call for app configure to say, hey, set this up. In Android, it's even less code. We call it in our Gradle file this plugin that sets up things for it. And in web, we just include JavaScript and call initialize app. As you can see, they're all slightly different because they feel natural in the environment that we're writing this code in. But the functionality in each environment will be the same. Now that we've looked at this, and we have our idea, a social photo chat, and we know we're using Firebase and we know we're focusing on web, then we can say, what do we want to use here? And this is an overwhelming slide. There's a lot of functionality here, and we don't need all of it for our app. We need to pick and choose. And this is one of the great things about Firebase. Every feature on here works alone. It can stand alone, and it will be useful alone. But you get more and more power with every one you include. So by mixing and matching 2 or 3 of these features, we're going to get a really rich experience for our user. But if you only want dynamic links, you only want crash reporting, you can always just do that too. So in this case, we're going to focus on these 4. These 4 Firebase features are Firebase Authentication, because we need log in. We want them to have authentication, so this is obvious. Then we'll use Firebase storage to deal with uploading and securing our uploaded files. We use Firebase real-time database to deal with synchronizing of messages between users and between devices. And then we'll use Firebase cloud messaging to deal with alerting them when they don't have the app open. That's weird. Ignore that animation. So let's talk about Firebase authentication.
All right, thank you. So as Abe mentioned, we are building a social chatting photo app today. And first off, we want a way for users to log into the app. We want to do this so that we can display their username to themselves and to the people that they're chatting with. We also want this for security purposes, to ensure that me as a user can only write to the part of the database that contains my messages and not to the part of the database that, say, contains Abe's messages. So I don't know how many of you have built an authentication system from scratch before. I've done this recently, and it was a huge headache. So I was just building a simple email password login for an app I was creating, and I had to learn about a lot of things, such as how to set cookies when someone logs in, how to have those cookies expire after a certain amount of time, revoke the cookies when they log out. I had this issue where a lot of my users couldn't log in for some reason, and after a lot of debugging, I discovered is because some of them wrote capital letters in their emails, and that caused a lot of problems. So I then had to sanitize the entire database, lowercase everything, remove spaces at the beginning and the end of emails. A lot of issues I didn't foresee that ended up taking up my time and preventing me from working on things that were really interesting. So with Firebase, we make something like authentication really simple to just put right into your app. So the things that we support is first, email and password authentication. Second, we can do custom authentication. So this is if you want to use something like a phone number plus password authentication, you can build that integration yourself. Or if you want to use a provider we don't currently work with, such as WeChat or QQ, for people to be able to sign in using those credentials. We also have built-in providers that you can put into your app that are commonly used around the world. Things such as Twitter, Facebook, and Google. If someone has one of those accounts, they can sign into your app. So the benefits of using Firebase authentication instead of building your own is taking care of a lot of the edge cases I told you about. But also we make it very easy to have the UI. So this that you see here, a list of buttons where people can pick how they want to log in. You can put this into your app with just one line of code. Secondly, we make password resets really easy. So this is something when I was building my authentication system, didn't consider at all. And then I was getting users emailing me or calling me saying, hey, I forgot my password, and then I had to go into my database, make sure I delete their current record, send them an email with a link to reset their password, a real pain. And if you're building an app that has thousands and tens of thousands, hundreds of thousands of users, you're going to be getting a lot of these password resets every single day. And something that should be really simple, like sending an email with a password reset link, actually becomes really complicated. Because when you're sending that many emails, you're going to be caught by spam filters, your emails won't go through, or they'll be very late in arriving in your user's inbox, making the experience very frustrating. So with Firebase authentication, you can do password reset. We even have email templates you can use and modify to have your own branding, and we make this whole process easy and secure for your users. Another thing that we do that is very helpful is anonymous accounts. So let's say you're building a shopping app, and someone might just be trying it out, and they'll browse around for about half an hour. They might put some things in their cart, and then they decide to buy it. At that point, you ask them to create an account. But you don't want them to lose all the data they previously had. You don't want them to have to go pick those items again and put them in the cart again. With anonymous accounts, even when someone doesn't sign in, you create an account for them right when they are on your webpage. And when they do create a real account, you then link that information and nothing gets lost in the process. So let's see how we do this in code. As Abe mentioned, we already initialized the Firebase instance. And next we, on line 3, call firebase.auth This gives us an instance of the authentication service of Firebase. And once we've done that, there's a lot of different functions and attributes that we have access to. So let's say you have a web form where someone has filled out their email and their password, and you store those variables. You have an email and a password variable. You want to now check to see if their password is correct. So you call this function on line 4, sign in with email and password, provided with these 2 parameters, and this will tell you if it is a user that has already signed up and if their password is correct. This function returns a promise. So if you haven't used promises before, it's a way to handle asynchronous code in JavaScript. It's an alternative to a callback. And with a promise, you get a then function and a catch function. So in the then function, this is the success case when the password is the correct one. You get in the function here a result which represents that signed in user. And result.user gives you everything that Firebase Authentication knows about that user, including their universal ID, their email, their password, maybe a picture associated with them, and you can store that in the user variable to use later. And let's say they typed in the wrong password, the catch function catches that error, and we have a code and a message that you can choose to display to the user if you would like. Let's see how we do this with one of our existing providers. We're using Google Sign-In in this case. So this is someone that has a Google account, and they want to use that to sign into your app instead of creating an additional account and another password just to remember for your app. So here in line 4, they create an instance of a Google Auth provider. So you can do this not only with Google, but also our other providers such as Twitter and Facebook, and you simply replace Google with those names. Next, they call the sign in with Popup function on the Firebase Auth service and pass in the parameter that we just initialized. So what this does is it creates a pop-up that will have UI asking for their Google credential. And all of this then goes to Google servers, not your servers, so you don't have to worry about security and storing the user's data or knowing their password to their Google account. And once they type in their credentials, the function again returns a promise with a then and the catch. And in the then, you get the success case, you get the user object with all the information you need, and if it fails, an error code and a message that you can choose to display to the user if you would like. Now let's talk about how you can do custom authentication. So this is useful if you are, like I mentioned, trying to integrate with a third-party provider we haven't supported yet, such as WeChat or QQ, or if you would like to work with an existing auth system you already have created for your app. So you call the sign-in with custom token function, pass it a function that was created on your server, either through third-party or your own custom auth flow. And in the success case, you would have the same user object you had earlier. And the failure case, you would have a message that you would display to the user. So now we figured out how to get someone to sign in. I just wanted to let you know that we here only looked at how to sign in, but for someone to sign up is a very similar flow, and the code almost looks identical. You just have to replace the function names. So instead of sign in with custom auth, it would be something like sign out with custom auth. Next, we're going to look at how to let user upload the photos once they've signed in, and A will chat to you about that.
Awesome, fantastic. So we're going to talk about Firebase Storage. Firebase Storage is the solution for dealing with uploading files. Once a user has authenticated, we want to give them a way to upload images, in this case, but in many cases this could be videos, it could be documents, PDFs, anything. This is a general solution for dealing with uploaded files. Firebase Storage is really great because it's backed by a very powerful system for storing files, and not only storing them, but securing them. So you can know for sure that a user who uploaded a file to their folder on Firebase Storage will only have access to that folder, and no one else can read or write to their folder. You can restrict how big of files they can upload. You can check and make sure they have the right MIME type, so you know they're only uploading the right type of file. You have a lot of options and a lot of control here. So to get started with this, in HTML, we have 2 elements which make up our simple upload form. We have the input type file, so that's where they'll actually select the file. We'll have a button that just says upload, and that's all we need. Once we get to JavaScript, we just have some boilerplate here to select those two inputs. So the input file is that type file input, and the button submit is our submit button. Then we have this add event click listener. Again, this is just normal JavaScript. This is not anything special about Firebase. But once we get down into this part, we get into all the magic of Firebase. So the first thing we'll want to do is grab the input file, that file is 0. So this will be the first file that the user has selected. Sometimes they can upload multiple files if they have multi-file select enabled, but in this case, we don't allow that. After that, we have the reference to the Firebase storage location. So Firebase storage.root, upload.jpg. So we're saying we want to upload this to upload.jpg. It doesn't matter what the file is that the person is uploading. If it is named, hello world 123, it will be uploaded to upload.jpg. And then below, we'll do ref upload. And this is the actual call to upload the file. And this is all it takes to store that file the user has selected on our server. Ref.put file takes the file that the input has specified. And then with that same promise function, we check, make sure it's successful, and then we log out, upload it. And then below here, we've assigned the download URL to this variable image URL. In this case, the download URL is literally just a URL to the image. We could embed this in an image tag, we could download it, save it to the hard drive, whatever we want to do. In this case, we're just storing it as a variable so we can later append it to a message to send off. There we go. Next, we're going to talk about the Firebase Database. Lauren?
Awesome. So let's think about what we've done so far. We made it available for the user to sign into the app. We then allowed them to upload a photo. Now let's allow them to chat. So Firebase Database is our solution for storing data. It's a very powerful one. It is a JSON-based database. So if you've worked with JSON before, anything that you can encode in JSON, you can store within Firebase storage. It is a key value store, so it's not an SQL-based database, it's a no relational database. The very powerful thing about Firebase Database is how it's real time. What this means is anytime one of your users puts something into the database, all of the other users that are listening to that same database will get that change instantly. No one needs to refresh their page for this to happen, and this happens within milliseconds. We also offer really great offline support. So if I'm typing a message and my connectivity goes out because my Wi-Fi is stopped working for some reason, then the chat I sent gets queued up, and when I'm online again, it gets sent to the database. Now this feature is really key if you're trying to develop for a market like India, where a lot of people have smartphones, but good connectivity is hard to find. So a lot of people have very spotty networks and spotty Wi-Fi. This is how we would store something. So this is what we're going to use today for our chat app. As you can see, it is JSON. It is essentially a tree of values. So we store everything in this top level chats node. And within chats, we have different chat IDs representing chat rooms. So today in our chat room, we've got 2 messages so far. Each message has its own ID. And in the content of the message, we have a UID, which stands for user ID. This associates that message with the user that sent it. We're also storing the content of that message in plain text. And when someone types in something, it goes to the Firebase database in the cloud. It then propagates to every other device that's connected to that database. So this could be if a user is using your app on both their phone and the computer at the same time. This could be people that are using the same app. Not that user, but other people that are in that chat room trying to see what messages are being sent. The synchronization happens very fast, and it does not require any of the users to refresh their page. So this is very powerful. This makes single page apps really easy to build. This makes the experience really magical and delightful for your users. And this is something that would normally be very hard for you to build by yourself. But today, as you'll see in the next few slides, it just takes a few lines of code. So here we get an instance of the Firebase database on line 1. Similar to how we set up the auth and storage, we just call Firebase Database. Next, we actually want to reference to the place in the database that we want to store the next message. So as you remember from our diagram that we went over, we have everything stored inside chats, and we have a chat ID for each chat room. So we get a reference to the place in the database with the path chats / the ID that we are on right now. And here in line 4, we have a helper function called sendChatApp, and this function is called whenever someone types in a message and clicks on the submit button. So when they've done that, we call a function on the chat ref called push, and we give push the content of what we want to store in the database. So this is the user ID of who sent the message and the message that they just wrote. Now there's other functions you can call on chat reference, such as set, and the difference between these two functions is that set is if you know the exact path to that place in the database, whereas push is useful when you're adding something to a list, and push also automatically gives that new item a unique ID, so you don't have to worry about figuring out how to randomize an ID and ensuring that they're unique with each new message that you are storing. So we've pushed it, so from the lines that are highlighted, this is all the code we need to write something in the database. Very simple. Next, we want to then make sure we know when someone has typed a message and then display that to the user. So line 12 to 14 shows us how we do that. So on the same chat ref that we just wrote to, we add a listener called child added and give it a handler. So child added listens to the event where something new has been added to that list of chat messages. So if either me or someone that I'm chatting to has wrote to the database, this function will fire. And it'll fire with a parameter called snapshot, which contains everything we need to know about that new database write event. So in this case, we can call snapshot.val on line 13 to get us the content that was sent to the database. We then have another function called display chat message, which we didn't show here, but this would just be a message for you to actually display it in the HTML. So check it out. This is all the code we have to achieve a real-time synchronization of messages across multiple devices in milliseconds. And another neat thing we can do here is connect storage and database together. So when Abe went over the storage part of the presentation, you might remember that we get back a URL that we can then use to download that image again. So if someone has sent a image along with their message, we can write that URL within the database. So when we display that message again, we not only display the message that they sent, we also display the image that they uploaded. So this is how you can connect together the storage and the database. So now that we've given the user the ability to sign in, write a message, and upload a photo, we want to notify them when they want to know something about what's happening.
Awesome. Yep, so if we want to notify someone when they're online, when they have the app open, when it's in the foreground, this is pretty easy. All we have to do is say nothing. We just did it. We wrote the code already. We wrote it with the real-time database. That's going to synchronize if a message comes on when the app is open. But if they get a message when they're offline, that code's not going to be running, is it? That code's shut off, the app has been killed, they don't have the tab open. They will not get any type of notification. This is where Firebase Cloud Messaging comes in. Firebase Cloud Messaging is a generic push notification solution. So it can push to mobile devices like Android and iOS. It can push to web browsers, which is what we'll be doing here. You have a lot of options for sending alerts to users who are not currently in your app. And you can even use it for in-app notifications if you'd like. But in this case, we're mostly focusing on the use of, I'm not in your app right now, but somebody sent me a message and I want to know about it. So setting this up is pretty easy, just like all the other code we've looked at. We get started with a messaging instance, so we get firebase.messaging, and then we call messaging.getToken. And this is going to get us a unique ID token that is generally said to refer to a device. In this instance, it actually refers to a browser instance. But the important part is that it is a machine, it is this user on this machine. Once we have this ID token on our server, we can go and we can send any given push ID or any given push we want. So we can say, hey, your friend came online, hey, you got a new message, hey, your billing expired, anything like that that we want to do, we can do with this token. And that's why when we successfully get this token, we send it to our server. And this function isn't shown here, but in actuality, this code would send to the real-time database probably, and we would have a map of saying, you logged in with Twitter with this UID, and associated with that user ID is this push token. Then, if for some reason we weren't able to get the token, we request permission, and it pops up a dialog for a user that says, hey, you need to do this so we can have push notifications, and then that can allow us to successfully get the token. So actually getting that token is really easy. And then, like I said, storing it, very easy, and then consuming that, sending push notifications to this specific user, very simple. If we want to catch that message, if we don't want to catch the message, and we just want push notifications to show up, so they pop up on the top of the screen and says, hey, you got a new message, we don't have to write any code. That's the default functionality of Firebase Cloud Messaging. So if I want that, we're good. But we actually want to go a little beyond that and customize it a little bit. So if I have the app open and I'm chatting to Lauren, I don't want to know when I got a message from Lauren in the form of a push notification, because I already have the app open. That'd be really annoying. Every time she sends me a message, I just get the same push twice, and that'd be really, really weird. So what we do here is we say messaging.onMessage and put on this callback, and we say anytime I get a message, if I have the app open, this code is going to catch it, and it won't show that actual push notification in the browser. If we want to, in our chat app, we can use this as a call to action and say, change the chat to be focused on Lauren, or wiggle her icon or something like that to say, hey, you got a message, but we don't have to show the native push notification UI if we don't want to, and that's what this is doing here. So we are cheating a little bit here. I'll admit there's some server-side code that would generally be used with this to complete this example, but Lawrence is giving a Firebase Cloud Messaging and Firebase Notifications talk right after this. So if you have a lot of interest in push notifications, definitely go to that talk, and he will explain in very good detail everything about implementing this. Cool. So we've pretty much completed our app with these 4 Firebase features. If we put these into a chart that kind of maps the user's flow, the first thing they do is they log in with Firebase Authentication. Then they're logged in and we know who they are. Then they take their picture, and we upload that to Firebase storage. And then as soon as they do that, we use Firebase Cloud Messaging and Firebase Database to send that out to all their friends. And we have a complete experience here. This is everything you need to build an app. So let's look at what we actually made here once you take this and add a little bit of polish. We have this original app that we looked at, and if we step through this, we have a sign in button. We hit sign in. We get that beautiful screen of all the different provider options you can log in with. In this case, we would sign in with Google because we're a little biased, but any of these providers are supported, and if you want to add custom ones, like we said, WeChat or QQ or any of these options, you can add those as Firebase Authentication login options. After we've logged in, we'll change our welcome message to say, hey, welcome Ben, welcome to our hashtag Golang chat room. And the previous messages that have already been sent will be displayed to Ben. And this is something really interesting about the real-time database that is often kind of unexpected. It's a problem that you don't really realize you have until you get really far into development, which is that if we were normally building a chat app with sockets and all of that painful stuff, we'd have to write a bunch of code just to send users who just connected all the historical messages. But with Firebase, it's super simple. We can go in and we can say, just give us every message, and that's what we did when we did that child added callback. So a new user entering this chat will automatically be caught up with every previous message sent. Or if you change the code a little bit, it might get the last 10 messages or the last 5 or whatever. So you don't have to worry about saying, oh, are they going to get the previous messages? Firebase takes care of that for you. So let's actually send a chat and look at this. So imagine we have another user. This one's named James, and he's somewhere across the world from Ben, and he's looking to chat. And Ben decides to write a message. He doesn't really like that we have a Golang chat room, but not a C# chat room. So he decides to write that in for us. And he sends this message. Now, as soon as he sends it, imagine no time has passed. 0 milliseconds has passed. James has not gotten an update yet. Nothing has happened. But over the next 10, 20, 30 milliseconds, we're going to see that Firebase magic. That's going to get sent up to the cloud and synchronized back down. And before James can blink, probably literally before he can blink, that'll be synchronized back to him. And and he can get that message. And we do a little cool, client-side logic to say on this one it's sent by you, and this one it's sent by Ben. So we're looking at the messages as they come in, customizing the UI a little bit. This is all super straightforward. And if you want the complete code for an example just like this, we have them available on GitHub. We have full chat applications where you can upload pictures and share and invite people in a chat room. All built on Firebase with little to no server-side code available online right now if you're interested in building exactly this. And this is the important part about Firebase. We just built this with no server-side code. We built an entire chat experience just using Firebase. So you can imagine if we take this and we ship it out to our users, you will never get a call in the middle of the night that says, hey, your chat is down, because Firebase is handling that. And if something does happen, if some outage does happen, we have a literal squad of folks whose only job is to make sure things get resolved. You won't be waking up, you won't be getting disturbed during dinner because your app is down. And this is the wonderful thing about Firebase. Once you build this, it's ready, it's out there, and you don't have to be concerned with all those ongoing maintenance issues. You've just got a chat that works, and works really, really well. So that's trying it. Let's ship it. Let's actually get this into production and see how hard it is to get this to our users.
Awesome. So we are going to be talking about another product, the fifth one actually, called Firebase Hosting. So hosting is how you get from your test app to an app that is available across the world. And normally if you want to get something out onto the internet, you have to buy a domain, you have to set up DNS, you might have to wait about 24 hours for it to propagate, and then maybe you can test it. If you want an SSL certificate, that takes extra effort. You have to activate it and integrate it with your website. With Firebase, we give you very simple commands you can use right within your terminal. So Firebase init is how you initialize a Firebase project before you start developing. Firebase serve opens up a local port and a local server that you can use to test your app. The really cool thing about Firebase serve is even though it's localhost, it talks to your real database and your real storage bucket. So you can test all of those things while you're developing. And when you're ready for your app to be launched into the real world, all you do is say Firebase deploy in your terminal, and you get it out onto the internet. We give you a domain, your app id.firebaseapp.com, but if you would like to connect a custom domain, you can do that as well. So we just shipped it.
Yeah, that was incredibly easy compared to any other solution for shipping a product like this. Firebase Hosting is absurdly simple. And what I love about Firebase Hosting, I love all of Firebase, but I especially love Firebase Hosting. Excuse me. Firebase Hosting because of how it came about. We did this thing at work called Experiment Week. And in Experiment Week, we say, hey, build something useful. Like we always have roadmaps and we're planning years ahead, but if we want to take a week to just try to build something that we think might be cool, we don't know if it's going to be useful, it's going to turn into anything, but we want to take that week and try. And one week, somebody said, you know what I really can't do? I can't find a place to put my HTML. That sounded like a silly question because there were other options out there, but they didn't fill these needs. They weren't fast enough. They weren't performant. So one of our engineers, Chris, he went out and he spent a week and built a prototype of Firebase Hosting, just for fun. And what came out of that was one of the coolest Firebase products. All of Firebase Hosting grew out of that 1 week experiment. And I think this is my favorite part about Firebase, and not only our internal culture, but what we enable people to do is to experiment. When you don't have to think about setting up authentication, and you don't have to think about how to synchronize data in real time, you don't have to think about all of these things, you get an entire new realm of ideas you can implement in a weekend, or you can implement in a week, and you can pitch to someone. You just get so many more options. And so this is what I want to encourage you to go do, is try this. Go be like Firebase and experiment, play around, and see what comes out of it. You never know what little idea that Firebase enables you to do is going to become the next billion-dollar business, because you really can just do so much more than you ever could before. So with that, I want to send you back to this slide of the 15 products. Now that we have a little more context, hopefully you have some idea about which ones might interest you. Like I said, if you don't want to use all of them, you don't have to. If you want to try analytics next to your existing analytics solution, you can do that too. You have a ton of choice and a ton of freedom here because we don't want to limit what you want to build. You can always check out our documentation for fine-grained details on firebase.google.cn, newly launched. I believe it was launched today, so definitely go check that out. And one aside, if you're interested in open source code, if you want to see what it's like to build stuff inside of Google, how we do things, what it's like to be a Firebase developer, we have like 90 open source projects at Firebase alone, not even the rest of Google. So if you want to come check us out, see what Lauren's working on day to day. She does a ton of open source. You can see our command line tools, see how we wrote that. You can see our framework, see how we wrote those. That's all available online, open source, for you to check out and build off and play with. Thanks so much. It was great talking to you. With that, we're going to take a couple questions. So anyone who has questions, feel free to yell them out, and if you have to get going, that's fine too. We have just a couple minutes for questions if anyone has anything super pressing. Go for it.
我问一下，这个 Firebase 就是我们把应用托管在上面会不会有收费？如果是收费的话，具体是什么样一个价格？
再说一遍，你是用 Firebase， 你是想怎么用？
根据刚才的讲解，就是我们可以把我们的应用托管到 Firebase 上面吗？
音乐托管能不能翻译一下？
应用，我说把我们的应用托管到 Firebase 上面。
明白了。
No, I can't. It's already gone.
Oh, okay. No worries.
That slide is readily available all over the place. So if
Yeah.
you go on Firebase.google.cn, it's up there too.
咱们大部分东西都是免费的像咱们今天学的东西都是免费用的，就是刚开始是免费的，但是你要是用了很多的 bandwidth， 你要是 store 不是太多的东西是免费，但是要是petabytes and petabytes 的，就是需要开始花费了。就是你开始用的时候肯定是免费的，你要是用的时间更多的 scale 就是开始加价格，然后你要是 scale down 的时候又可以变回免费。
你好，我的英语也不太好然后我想说的问题就是，咱们现在这个 Firebase 是属于刚开始运行时期嘛，这是第一个问题。第二个问题就是说，我们这个 Firebase 如果说能够承受多大的用户量，假如说达到一定的量级的时候，如果说会不会出一些意外？假如说第三个问题就是，如果出了这些意外的话，如果说我们不是收费的用户，那么出现了一些用户上的责任问题，是需要我们自己承担的。也就是说，主要归结的两点就是，第一个是咱们现在这个 Firebase 是刚开始运行，是不是运行时期的这个阶段？第二个就是，如果说我们一旦把自己的一些项目投放上去，并且运用 Firebase 的时候，出现了一些责任性的问题，那么也是由我们自己来承担嘛。也就是说，这个靠不靠谱？
听明白了，谢谢。Firebase 现在是不是 beta， 现在是 production， 就是说咱们的real-time database 5年前就开始用了，所以都已经有5年的经验了。其他的东西咱们是去年的 IO launch 开始的，所以咱们所有说的东西都是已经是 production， 所以不用担心。